RxJava can add an immense amount of quality to your app, but it can also be very difficult to unit test. If you don't know how to do it properly, it's easy to skip over it, leaving big holes in your unit testing coverage. Thankfully, you don't have to struggle with this concept. All it takes is a good understanding of the fundamentals, and you can become a pro. Today, I'm going to show you 6 very common techniques that I use to properly unit test my RxJava code, including some head-scratching scenarios that could throw you for a loop if you weren't prepared for them. But you're going to be prepared for them. Let's take a look at one example that returns a single or completable or some other type of observable, and we need a subscribe on the outside of our function. Unlike unit testing in most scenarios, RxJava is embedded directly into the UUT. In fact, it's a part of UUT, but you're not going to mock RxJava. Instead, you're going to use it to drive your code. You're still going to test your code, and you're still not going to test RxJava, it's just thrown into the mix. Let's take a look at this very simple example. As you can see here, I'm not doing work on any extra schedulers, I'm simply working with the bare necessities of RxJava. My code is on the left, and the test is on the right. The goal here is to catch the outcome of this operation. So, in that sense, I'm going to need to subscribe. So this is just like calling any other function that returns an observable. All I'm interested in at this point are 2 things: if there were any side effects, and then of course the final outcome. So the way that I typically deal with this is I'll make some variables up above and record what happened in each of those callbacks. So as you can see here, I have 2 variables. One that catches the outcome of the operation, and another one that checks whether or not an error ever happened. And then from here on out, I'm home free. All I'm doing is checking the values of 2 variables. For this next example, let's take a look at a function that has a subscribe inside of it. So in this case, unlike the first one, I'm not able to observe the outcome directly. Instead, I have to look for the side effects. For this scenario, we can sort of think of this as if RxJava wasn't there. And if it's easier for you to conceptualize it this way, then go ahead. But why is this important? Each of the UTs are effectively considered to be black boxes. We don't really know what's going on inside of them from a testing perspective. So things that we don't have access to inside the test, we can effectively just dismiss. So in this example, where we have a networking response we're making to a server, there's really 2 things that are happening here. What happens on success and what happens on failure. Let's focus on first what happens on success. So there's 3 areas that I need to look at whenever something successfully happens. Do unsubscribe, because that always happens when you subscribe, the flat map operation, and then of course the final result. Any case in there where I have some sort of side effect, such as a property being set or some other function call being made, that's something that I can go ahead and unit test. So as you can see in do unsubscribe, I have some sort of loading indicator that shows up. I'm going to make sure that that's called, and then in the end, I want to make sure that the data is displayed in the final state. That's being done with a secondary function call that I can also observe. Notice how I ignored the flat map altogether. Because I don't have access to any sort of side effects or what's going on inside of there, I just ignore it, and I wait for the things that do matter to me on the outside. Now let's take a look at the error scenario, and this is going to be very similar. My networking service should then return an error with some sort of exception or throwable, and then I need to consider what RxJava is calling in the error scenario. As before, do unsubscribe is always called, so I need to make sure that my loading state is set. And then finally, in the error block, I need to make sure that the error state on the UI is shown. Notice how with all of this, I'm not actually testing RxJava. All I'm doing is using it to help me reach all of the branches inside of my code, and then I can trigger those cases from the outside through my mocks. When you look at it this way, the RxJava simply falls away, and then you're just dealing with the logic flows inside of the code that you wrote. Now let's move on to the third example, which is really just an extension of the previous case. Admittedly, the last example wasn't very practical for client-facing applications because I made a network call on the UI thread. I need to switch to the background thread before I can make a call to the server. And to do that in a way that's testable, I'm going to use what I call an RxJava factory. This is effectively a class that I can inject with DI. And inside of there, I have 2 properties. One that allows me to get access to a background thread pool, and one that allows me to get access to the UI thread. Let's go ahead and inject this factory into my class, and then use it to make a network call on the background thread. As you can see here, now this is using the IO thread pool to make a network call. And then finally, I observe the outcome on my UI thread. From an application perspective, this is going to work just fine. But for tests, we're going to have to use fake thread pools. RxJava calls these test schedulers. So the first thing I'm going to do is mock my RxJava factory. And in this case, I'm going to have it return test schedulers. If I run my tests right now in their current state, they're never going to finish. And that's because I need to use RxJava to drive these schedulers. After I've called my function on the UUT, then I need to call the trigger actions function on both the IO and the UI schedulers. Notice I'm calling the trigger actions function on the schedulers in the exact same order that I have them in my implementation. That's important because RxJava needs to run these test schedulers in the exact same order that they're going to run in production. From here on out, the tests are the exact same, except now I'm running my RxJava chain with test schedulers. Let's look at a slightly more complex example. In this case, I'm going to be switching between multiple schedulers just to make a point, not because it's actually necessary for this example. Imagine that I have two networking calls that I need to make on background threads, with one operation in the middle that needs to run on the UI thread, and then of course the ultimate result will be on a UI thread at the end. So effectively I'm going to be going from the background thread to the main thread, and then back to the background thread, and then once again on the foreground thread. We have all of the plumbing in place from the previous scenario. Let's just see how it works in a more complex scenario. Unit testing this requires calling trigger action each time we switch our threads. Not just once for the UI thread and not just once for the IO thread, but you need to trigger the waterfall of calls each time you switch contexts. And I need to do it in the exact same order. So in this case, you can see I'm calling trigger actions 4 times because I switch contexts 4 different times. And of course, these calls are happening in the exact same order as before. So I call trigger actions for each of these times. Once for the background, then for the foreground, then to the background, and then to the foreground, because that's the way it's going to run in production, so that's the way it's going to run inside my tests. This next scenario deals with timeouts. It can be really handy to use RxJava to help you deal with them, especially whenever you're dealing with networking and you want to gracefully handle a timeout. Here is a network call with a 5-second timeout. Notice how the timeout function has an IO scheduler as the third parameter. That's going to be really important for allowing us to drive this properly inside of our tests. The updates to my test look like this. You can see in this example, I do have RxJava returning a value, but it's delaying it by something greater than 5 seconds, which is my timeout. So in this case, I used 10 seconds. After 10 seconds, it's going to return some sort of response, and that's obviously going to trigger a timeout. Now, it doesn't really matter whether I return an error or something successful because really at this point, the client won't care. I've already timed out. Now, if every time I add a timeout to my tests, I have to wait 5 seconds or 10 seconds in this scenario, that's going to take a lot of time for my unit test to run. There's got to be a better way to do this. And of course, there is. We're going to use the test scheduler to go into the future. After I've called my function, which is going to make the networking call, I'm going to call advanced time by on the IO scheduler for some value greater than 5 seconds. So let's say I do 6 seconds in this case. All of this work is going to be happening on the IO scheduler because that's where the networking is going to be happening. RxJava has more time-based operations than just timeout. They have timers, delays, and intervals. Let's take a look at this. All of these time-based operations run on what's called the computation scheduler by default. If you want to use your own scheduler, you have to override it with your own value. That's done by providing a third parameter to each of these functions. This is a very important point because it doesn't actually matter whether you're subscribing or observing on something. These time-based operations are always going to run on their own scheduler, again, unless you provide your own. That will make these time-based operations controllable from your tests. Since I'm on the topic, let me clarify something really quick. What's the difference between timer and delay in RxJava? A timer is when you want to do something after a particular amount of time. So what you do is you wait first, and then you do some sort of action. A delay is the same thing, but in reverse. A delay is when you do something first, then you delay some sort of subsequent operation, and then you do the rest later on. So let's unit test our timer real quick. We're going to add the IO scheduler as the third parameter. And then whenever I call my function, I'm going to advance time by on that IO scheduler by however much time I want and make sure that either the action happens or it doesn't happen, depending on how much time has passed. The idea is very similar with using a delay or an interval, except of course with an interval, you're going to have something happen multiple times depending on how far you advance time into the future. Unit testing with RxJava can be confusing, but it is extremely important to test. Using these 6 techniques, I've been able to test just about every nook and cranny of my RxJava usages in my production code. If you're a bit confused about the threading concepts I used in this video and you would like more clarity about how it works in RxJava, continue on to this video here. I hope to see you next time on Thought Fuel. Thanks, and happy coding.